Hi, in this video, we'll see how you can use NCD vibration sensor to predict a motor's health and other parameters. So to do that, we'll be using NCD PR5567. We'll be using PR5561 product, which can be found here. This part comes with a multiple options of mounting. In this particular test case, we'll be using a magnetic mount. It's easy to use. And I have a motor, as you can see in this picture here. I have a motor which is a small 1 horsepower motor, and will can change the frequency of the motor and can measure the parameters as we go along. For testing, debugging, and getting data to the cloud, we recommend that you use Node-RED. NCD has a plenty of Node-RED resources available. So if you're new to Node-RED, check out ncd.io, and the first thing you will do is you will install the NCD Red Wireless 2 library if you're using a computer, and then you will install Node-RED dashboard. Those two are the libraries you would install. Once you have that, you can copy this flow from the NCD GitHub repo. If you want to build your own, you can do that also. By default, the sensor is sending data after every 15 minutes. In this demo, I will change that to 1 minute so we can do it really quick. To do that, you'll need to configure the sensor. And to configure, the step one is put the gateway into configure mode by clicking this button here. Then go to your hardware and then press and release the R button and then hold the C button for 5 to 6 seconds. While you're holding the C button, you will see the LED will come on. Once that's done, you will see that it will say configuration acknowledged, and once it's done, it will say configuration complete. Always go here and check if all the configurations went through or not. If they did not go through, then you will need to do it again and do the same way. How all the settings are changed over here. First of all, we are telling the address like, hey, send data to this particular receiver, the wireless gateway. Then node ID delay, this was my bad. Make sure this is unchecked. Screw up. So make sure this is all. If you're using node ID, make sure this is always 0. So this value should always be 0. Power by default is this one, so you don't have to change. Retry default this, don't change it. Filtering by default is enabled, we'll recommend you keep it. Measurement mode by default is velocity in millimeter per second, displacement in millimeter. We'll recommend keep that. On request timeout by default is 4 seconds, you can keep that. Default data rate is 800 kilohertz, you will keep that also. And sampling interval 1 minute. You can check out what ODR means. There are a bunch of options. These options you will change based on what is your motor speed. Always keep the value of so let's say your motor is running at 50 hertz. Then the value of ODR should be at least 3 times. So the next one, 50 multiplied by 3 is 150, and you can go 200. If you can go 400, it won't hurt. You can go 800, it won't hurt. But don't go too far up, then you will start to lose the lower frequencies, because it is a band pass filter. If you go too high, you will start to lose the lower frequencies. So keep a sweet balance here. Then RTC by default, this was a real-time clock, so it means you have 50 sensors. They can all send data and can sample data at exactly same time. Full scale range 4G by default is 16G, and you can keep that one, so don't have to change this one. All these are by default enabled, so won't change it. I will do it one more time, the configuration, because we had the delay set to wrong value. So let's do that. Let's talk about this also. So there are 3 modes of operation for this device. One is processed mode. It means sensor will take a bunch of raw samples and it will process and go through FFT, and then will send you final results over the wireless. This packet is around 75 byte long. Raw data is, you can ask sensor to sample for a predefined time and like sampling interval, and at what ODR, then it will send you raw samples, all of them, and you can process on the receiver side. So the benefit is that you can see every single raw byte. It means you can process and extract as much information as you need from the sensor. The downside here is that there is so much data on the RF. It means you can't have a bunch of sensors sending data at the same time. So they both have their upside and downside. We recommend that you use process and plus raw mode. A process and raw mode is like it will send process data, and if you see like, hey, values went high, so let's request raw data so I can do processing and can squeeze out every single bit of information I need to take any further action. So you can use that. Let's go ahead and reconfigure it. Confirm deploy. To do that, I'm just gonna put the sensor into configure mode one more time. Press and release the R button, hold the C button for 6 seconds. Then release the C button. You will see it got a configuration acknowledged, and it will soon say configuration complete. Once it does that, we'll check if everything went through or not. Configuration complete. Let's go and check. So everything went through. Now you will do uncheck this. We'll say ready, and your next task will be just press reset. Right now is motor is off, so all the data we should see should be 0. So let's see what happens. So ODR is this, mode is 2, raw request, and then all this data is 0. The motor I have is running at 68 Hertz, the frequency. I'm gonna turn it on and we'll see what happens. So the motor is running, and I have the sensor mounted on top of the motor. We'll wait for a minute for the next packet. Should be getting here at plus 5 seconds. Okay. Now, as you can see, the temperature, which is measuring the ambient temperature at the sensor probe, 24.58 degrees Celsius. Acceleration in G, in x-axis, this is RMS, is 1.2. Maximum is 0.148. Velocity is x-axis is this, y is this, and frequency is 67 Hertz. Then we get so what these means, this measures the highest peak or energy, acceleration energy was recorded, or vibration energy was recorded at this particular frequency, and same values will go for x and y and z axes. You should learn more about what frequency means, what acceleration means, what velocity means in the vibration manuals. There's detailed information there. We just got the second packet. This sensor has the art. Now I'll go ahead and increase the frequency to, let's say, 83 Hertz, and wait for the next packet. Here it is. So our machine frequency is right now 83, and we are reading around 81, and we're reading XYZ axis and all this. So this is a fairly simple demo for the sensor, and there's tons of things and settings you can always try and make a good use of it. If you need more information, you can always go here, click on resources and click on product manual, and it will talk about all and everything you need to know about this particular sensor. If you have any questions, just let us know. Thank you.